What I want to do in this video is I want to take a look at another function, and this function is going to be a piecewise defined function. Especially when you're dealing with limits in a calculus class, you look at a lot of these, and typically, I don't know how much, you really probably aren't going to see functions quite like this in real life, but when we're talking about these limit examples, they can really be pretty helpful to help describe what actually goes on when we take the limit of a function. So anyway, let's do this. And let's say we've got a function f of x. And f of x is going to be equal to a whole set of different things. So we're going to say here that f of x is going to be equal to minus x. And I'm going to say let's say from minus infinity less than x less than 0, let's say. So that means for all values of x less than but not equal to 0, that our function is going to look like the minus x function. Y is equal to minus x. So actually, I'm just going to draw that right now real quick. And actually, I've already screwed up. So it's going to look like that. It's just going to be slope with y-intercept at 0. And actually, one other thing to note is this going to be, I might have written this in kind of a strange way right here, but at our origin right here, is this going to be a closed circle or is it going to be an open circle? Do we know that x is going to be equal to 0 there or not? And I guess you can hopefully see that this is going to be an open circle at x is equal to 0 right there, because we say for all x that is greater than negative infinity, but also less than but not equal to 0, our function is going to be defined as minus x. And so now let's put in the next part. We're going to say f of x is going to be equal to 2 for, let's say, x is equal to 0. So when x is equal to 0 right here, our function is going to be defined as 2 right at that point. And then let's add in one last portion. I'll do this in yellow. And then we're going to say that our function is going to be equal to x squared for 0 less than x less than infinity. So anytime that x is larger than 0, and again we are going to have our open circle right there, our function is going to look like this parabola that we saw in the last video. So that's 1, 2, 3, 4. So that is what our function is going to look like. And so now the question that I'm going to ask you is, what is the limit? What is the limit as x approaches 0 of this function f of x? And I want you to think about this, and especially think about how we've been saying in these videos so far that we don't care what the function we don't care what the function is actually defined at the point we're talking about. So if we're saying here, what we're asking for is what should the function be defined at? If we were just looking at immediately what was right before 0, what was just a little bit more negative than 0, and also just what was a little bit more positive than 0, and we were getting closer and closer to 0, what is the value of our function approaching? What value are we approaching as we get closer and closer to 0? And it's interesting because the answer, and hopefully you can see that the answer to this is going to be 0, even though that's not what our function is defined as. At this point, our function is defined at f of x is equal to 2 for x is equal to 0. But both sides of our function, we have we've got this function for all negative x that's just a slope of -1 and a y-intercept at 0. And then we've got this function of x squared, which also intercepts at 0, 0. And both of those functions, from both the negative side and the positive side, are both approaching 0 as we get closer and closer to 0. And you could say that no part of this function, it's not like we've got some part of this function that's, going up to this this point at 2. No part of the function is approaching like that. We just have this 2, this point at 2, kind of defined as an outlier. And I know that I said at the beginning, and I don't know exactly how many functions really are going to be defined this way, where you say, okay, we've got one function for one set of values, another for another, and then another for another set of values. I don't know exactly how many functions are going to be defined that way outside of the limit section of your calculus textbook, but these are actually pretty good tools for helping you really get your head around what the concept of a limit is actually asking for. We don't care at all what the value of the function actually is. The value of this function at x is equal to 0 is 2. All we care about is what does it approach? And it doesn't approach 2, it approaches 0. So anyway, I guess that is, I think I'm going to end this video here. In the next video, I'm going to, I guess, just keep talking a bit more about limits and when the limit of a function exists and when it might not exist. And anyway, I guess I'll just see you in the next video. Thanks for watching.